Hey guys, I'm back with a new video. In this video, let us learn about how we can remove a node from the end of linked list. So removing a node from the end. Now here also we need to check for three cases. When the size of linked list is 0, so this is case 1. Case 2, when the size of linked list is 1. And case 3, when the size of linked list is greater than 1. Now these two cases are exactly the same as we had discussed in the previous video for removing a node from the start of the linked list. So for size 0, we will simply say underflow. That is, the linked list size is 0, so we cannot remove a node from an empty list. Now coming to case 2, when the size of list is 1, which means we are having only a single node, and that single node is both the head as well as the tail of the linked list. Let us say it has a data of D. Now in order to remove this single node, the steps are same that we had discussed in the previous video. We first need to set the head and tail to null, which means that head and tail now will no longer point to this node with the data of D. And then we need to set the size of the list to 0. So this is for case 2. Now let us come to case 3, when the size of the list is more than 1. Let us say we have this linked list with data 1, 2, 3, 4, 5 and 6. Let us say the indexing starts from 0, 1, 2, 3, 4 and goes till 5. Now in this case, in order to remove a node that is sitting at the tail of the linked list, which is 6, the very first step is to collect the data that we have in the tail node. So let us say we have a variable temp, and in that we will place the data for the tail, which is 6. Now the next step is to get the reference of a node which is second last of this linked list, that is, which is present right before the tail of our linked list, which is this node. So this is our second last node, so we need to get this node, and for this we will make use of our getNodeAt function that we had defined in the previous videos. So here we will have a reference second last node. Now in order to remove the node that is sitting at the end of the linked list, which is this one, at which currently our tail is pointing at, we need to set the tail to the second last node. So let us remove this and make tail point to 5. So tail will now come to 5, and now both the second last node reference and the tail is pointing at 5. So now what happened here is that the node that was the second last node of the complete linked list is now the tail of our linked list, that is 5 is now the end of our linked list. And also let us set the next of the second last node to null so that this node gets completely eliminated from our linked list. So once we do this, our list will look something like this. So now 6 is gone, and then we can do a size minus minus, that is, initially we had a size of 6 and now it becomes 5, and then we can return temp, which is having the data of the node that we just removed. So this is how we can implement all the three cases of removing a node from the end. So let us head over to Visual Studio Code and code this out. So right here, let us define a method to remove the node from the end of the linked list. So int remove from end. And here also we need to check for three cases. So first let us copy these two cases that are the same for remove from end as well. So if the size of the list is 0, it is underflow, and we can simply return -1, indicating that we cannot perform the removal for this case. Else if the size of the list is 1, we can call the handle one size removal function that grabs the data for the head node, which is the only node for the case when the size of the list is 1. Once we have the data for that node, we can set the head and tail for that single node to null and set the size to 0, indicating that now there is no more nodes in our linked list, and then we can return the stored data for our only node right here, which gets returned from here as well. Now coming to our third case, when the size of the list is more than 1, as I explained. In this case, in order to remove the node that is sitting at the tail of our linked list, we first need to store the data that is present at the tail of linked list. So int temp tail.data. So now let us define a reference to the second last node of our linked list that is just prior to the tail of our linked list. So node previous node get node at. So this function we had defined in the previous videos. If you haven't checked out the video on the linked list series, the links for those videos can be found down below. So to get the second last node, we can say size minus 2, because the last node will have an index of size minus 1. So if you have 5 nodes, the last node will be at index 5 minus 1. The second last node will be at index 5 minus 2, which is 3. So if you have size number of nodes, then to get the second last node, we can say size minus 2. Now in order to remove the node that is sitting at the end of the list, let us set the tail to the second last node of the linked list. So tail, this should be second last node. Second last node. Now since the second last node is going to become the last node of our linked list, let us set the next of the second last node to null so that there is no one present right after it. So second last node dot next, set that to null. And now let us also decrement the size of the linked list by 1, because now we have removed a node from the linked list. So size minus minus. And let us return the data of the node that we just removed. So return temp. So this is the entire implementation for remove from end function. So let us try this out. So linked list dot remove from end, and then we can say linked list dot display. So let us compile the code and run the file. So java c linked list dot java, and then to run the file java linked list. And here you can see we have successfully removed the node that was present at the end of the linked list, which was having a date of 5. So initially we had 2, 7, 3, 4, 5, and now 5 has been successfully removed. So now we are having 2, 7, 3, 4. So this was all I wanted to cover in this video. Let's proceed to the next video where we'll see how we can remove a node that is present at some specific index that lies within the bounds of the linked list. So let's catch up in the next one.